The Andromeda Galaxy revealed that the universe and creation do not revolve around us, proving that the Milky Way is not the only galaxy and that we might be just a speck in a much larger cosmos. Over the past century, we've learned a lot about Andromeda, primarily from Earth-based observations. However, with tools like the James Webb Space Telescope, our understanding has drastically changed. The data from this telescope has shocked the scientific community, revealing truths about Andromeda we couldn't have imagined a century ago. A century ago, the Milky Way was thought to be a faint, white band of light stretching across the night sky. This perception was influenced by the limited technology of the time, which prevented astronomers from distinguishing individual stars within the Milky Way. Galileo Galilei, the Italian astronomer, revolutionized our understanding in the early 17th century using his newly developed telescope. He discovered that the Milky Way was not just a band of light, but a massive collection of individual stars, planets, and other celestial objects, challenging the prevailing Aristotelian cosmology. We now know that the nearest galaxy to the Milky Way is Andromeda, and there are approximately 100 billion galaxies in the observable universe. This means that there are more stars than we could possibly count. Edwin Hubble made a transformative discovery in the 1920s using the 100-inch Hooker telescope at Mount Wilson Observatory. By observing distant nebulae beyond the Milky Way, Hubble showed that these objects were, in fact, separate galaxies, each containing billions of stars. The nearest of these is the Andromeda Galaxy, also known as M31. Andromeda has a rich observational history dating back centuries. One of the earliest known records of this celestial object comes from Persian astronomer Abd al-Rahman al-Sufi in the 10th century. He described it as a small cloud in his star maps, highlighting its faint appearance when viewed from Earth. Andromeda was further detailed in 1612 by Simon Marius, whose work laid the foundation for future astronomers to study this massive cosmic structure. In 1764, renowned French astronomer Charles Messier cataloged it as M31 in his famous Messier catalog, mistakenly attributing its discovery to Simon Marius, unaware of al-Sufi's earlier work. A significant leap in understanding came in 1864 when British astronomer William Huggins analyzed Andromeda's spectrum, revealing that it was different from typical nebulae. This paved the way for recognizing Andromeda as a galaxy in its own right. Despite being 1 to 2 trillion times the mass of our Sun, Andromeda is relatively close in cosmic terms, believed to be around 10 billion years old. This suggests a long and complex formation and evolution history, likely involving the merging of several smaller proto-galaxies over billions of years. Astronomers initially thought Andromeda was much larger than the Milky Way. Recent findings, however, have led to a reassessment. New data suggests that Andromeda's mass estimates have been revised down, while the Milky Way's mass estimates have increased. Andromeda's physical dimensions are still impressive, with a diameter of about 220,000 light-years, dwarfing the Milky Way's estimated 100,000 to 175,000 light-years. One of the most fascinating features of Andromeda is its active galactic nucleus, AGN, powered by a supermassive black hole with a mass estimated at 110 to 230 million times that of our Sun. Andromeda also hosts about 460 globular clusters, dense collections of stars that orbit the galaxy's center, offering insights into its cosmic history and interactions with smaller galaxies. Scientists predict that the Milky Way and Andromeda are on a collision course, set to merge in about 4 billion years to form a new supergalaxy. This collision will dramatically reshape both galaxies, leading to massive changes. As they draw closer, immense gravitational forces will distort their shapes, leading to tidal interactions where stars, gas, and dust are drawn between the galaxies. The merger will trigger bursts of star formation as gas clouds collide and compress, creating new star birth regions. Stars will undergo significant orbital changes, with some being ejected from the new galaxy while others settle into new elliptical orbits. The supermassive black holes at the centers of both galaxies will eventually merge, forming an even larger black hole. This process will also increase cosmic radiation, potentially impacting Earth's climate and biosphere. The interaction between stars, gas, and dust will lead to the formation of new galactic structures, transforming the night sky into a cosmic light show with new constellations and star arrangements. While the merger will profoundly impact the cosmos, it will also affect life on Earth. The increased cosmic radiation and gravitational disturbances could lead to changes in habitats, shifts in biodiversity, and even local extinctions. The collision could disrupt the solar system, affecting Earth's climate, weather patterns, and ecological balance. By the time this merger occurs, humanity as we know it may no longer exist. Our species, or its descendants, will have evolved significantly, facing the challenges of surviving in a vastly different environment. The merger raises questions about the fate of our solar system within the new supergalaxy, with the possibility of being ejected into intergalactic space. Despite the immense changes, this merger also offers the potential for new habitable zones where liquid water and life could exist. The stability of the new galaxy's structure will play a crucial role in determining whether life can emerge and thrive. The interactions between stars and gravitational disturbances could impact planetary orbits and environmental conditions, affecting the evolution and sustainability of any potential life forms. In conclusion, the collision and merger of the Milky Way and Andromeda will be a testament to the immense forces and mysteries within the universe. This event will significantly impact the evolution of life and the cosmos, offering scientists a unique opportunity to understand the dynamics of galactic interactions and the future of our universe. The new galaxy will represent a new chapter in the history of the universe, with the potential for life to adapt and evolve in ways we cannot yet imagine. However, the current form of humanity will not survive to witness this event. This cosmic transformation will be a reminder of the ever-changing nature of the universe and our place within it.